Alrighty, folks, this is part one of your spring 2017 final exam review. I'll work through all the problems on this sheet, and then on the second part, where the packet that had 31 problems on it, I'm only going to work selected problems because a lot of the problems kind of duplicate, just numbers change. So for number one, we have to use the mustache method. In using the mustache method, you must start on AB side, but you have to start at part AD. So this entire side is AB, but we have to start at a part, and we're going to pick AD to start at. When you use the mustache, you start at AD, come around the corner, hit 6, leave 6, come back around the corner, and hit AB. So when you write your proportion, you would put AD over AC is equal to AC over AB. And now fill in with the correct numbers that were presented. AD is 4, AC was 6, and AB we don't know. We could call it X or we can leave it AB. Either one is fine. And now we solve the proportion by cross multiplying, of course. So 4 times X, 4X equals 6 times 6, 36. Then divide both sides by 4, and X is equal to 9. In other words, AB is equal to 9. All right, I'll work number 5 out since I'm already at the top. So I won't have to do a bunch of scrolling back and forth. Number 5 wants us to write the equation of a circle with center at 4, -3, and passes through the point 0, 0. The correct format for equations of circles is always x minus h squared plus y minus k squared equals r squared. This can be found on your formula chart. All right, and so anytime they give you the center, that point is always your h and k values. And then the additional point that they give us we'll use in place of x and y. So x is 0, y is 0. H is -3. Sorry, h is 4. And k is -3. So the only variable that didn't get replaced is r. So we're going to use the numbers that we have substituted already to find r. Okay, so the first thing you would do is 0 minus 4, which gives you a -4. And then 0 minus -3, that's a double negative, so it's 3. -4 squared will give you a positive 16. 3 squared is 9. Add 16 and 9, you get 25. And then if we want r, we have to take the square root of both sides. So 5 is equal to r. So that entire process was done so that we can find our radius, because in order to write the equation of our circle, we need a radius and we need a center. Initially, we didn't have our radius, so that was the point of doing all of this work. Now we still got to answer the final question, which is write the equation. So when I write the equation, I still use parentheses. X turns back into x. H is still going to be 4, so we have x minus 4 squared plus y turns back into y. And then don't leave double negatives. It's just a headache for no reason. So anytime you have a double negative, automatically just change it to a plus sign. So it'll be y plus 3 squared is equal to 5 squared, which is 25. So this is our final equation. This is what was needed. But we couldn't have done it without our radius. Number 2 tells us the diameter of circle A is 26. The diameter of this circle is represented by segment BE, so the total distance across the circle is 26. CD is a chord and and its length is 10 centimeters. So whenever you have a diameter intersecting a chord, it's always going to be perpendicular, indicated by the right angle right here. And it's always going to cut the chord into two congruent parts. So CD becomes 5 and 5. Okay, and since my diameter is 26, that means my radius, which is AB and AE, are equal to 13 because the radius is half of your diameter. Now, before we can go any further on this picture, we need to add another radius. The best radius would be to connect A with C or A with D. Either one would work. And when you've done that, you have now created a right triangle within your circle. So the right triangle is triangle AFD. If you were to turn it around, the right angle is exactly right here. It's now if I add the labels, D to F is 5 again because that was part of CD. A to D, since it's a radius, that means it's 13 because the radius is always half the diameter. So now our last question is to find AF, which is part of this triangle. And since it is a right triangle, we can use Pythagorean's theorem. And since we've used Pythagorean theorem so much this year, I'm going to use the shortcut. So I have C and I have A. So AF is going to equal the square root of 13 squared minus 5 squared. And when you plug all of that into the calculator exactly like this, you would get 12 centimeters, correctly labeled. Number 6 wants us to find the length of arc AB. The formula for the length of arc AB is m over 360 times 2 pi radius. Now on the formula chart, it'll tell you diameter times pi or pi diameter. You can use either one of these. They will get you the same result. M stands for the measurement of the arc, which should be in degrees. And R, of course, is the radius of the circle. So the measure of arc AB is the same as this angle ARB because that is a central angle. So that means this arc is 135. So that goes at the top of my fraction. And then the radius is 8, labeled on RB. RB is a radius and it's labeled 8. Now let's find this in terms of pi, meaning we don't put pi into the calculator, but it is part of the results. When done correctly, you would get 6 pi inches. So any formula that involves pi, the best thing to do is to leave the answer in terms of pi. Please leave all formulas that have pi in them, leave the result in terms of pi. It just clears up any potential rounding errors that y'all might make. So let's just avoid them at all costs. Number 3 wants us to find the perimeter of the triangle being BCD. Assume that segments that appear to be tangent are tangent. So on this circle, the tangent lines would be CB and CD because the definition of a tangent means it touches the circle at one point and only one point. Now, when you have two tangents meeting outside of the circle at the same point, those two tangents are going to be congruent. So CB is congruent to CD. So that means I can put 5n plus 11 equal to 8n minus 4. Now I can solve for n using my algebra skills that I have. The first thing I would do is subtract 5n from both sides, leaving me with 11 equals 3n minus 4. The next thing I would do is add 4 to each side, which would give me 15 is equal to 3n. Then divide both sides by 3, which gives you 5 is equal to n. Now that we know what n is, we're going to take it and substitute it back into each side of the triangle so that we can find the measurement of each side. So for this one, it'd be 5 times 5 plus 11, which would give me 36. This one is 8 times 5 minus 4, which would give me 36 again, which makes sense if they're supposed to be equal. And on this one, and that's a way to check your algebra. If your algebra is wrong and these two sides don't give you the same value, then you need to go back and figure out what part of your algebra step did you go wrong. And on this last piece, it's 4 times 5 minus 3, which would give us 17. Now, final step, to find the perimeter, you take all three sides, add them together. So 36 plus 36 plus 17 is going to give us a grand total of 89. For number 7, it tells us that BD is 12 centimeters. BD is a diameter as it stretches across the entire circle. It wants us to find the sector area formed by the angle AQE, which is this area right here. The formula for sector area, which again can be found on your formula chart, is m over 360 times pi radius squared. Again, m stands for the measure of the arc, and r is your radius. So to find the measure of this angle and arc, because they're going to be the same, you know that BD is a diameter. So it cuts the circle into half. A whole circle is 360 degrees. So that means each half has to be 180. So down here, this angle BQC is 100. So that means this angle up here has to be 80. And then 80 plus 50 plus whatever is in yellow has to equal 180 as well. So this one would have to be 50 because 50 plus 50 is 100, 100 plus 80, 180. So the measure of arc AE is going to be 50 as well. And since BD is a diameter, we would need to divide it by 2 to figure out what our radius is, which is 6. So again, we're going to leave this answer in terms of pi. When you put it in the calculator correctly, you get 5 pi centimeters squared. Again, If it's area, your units have to be squared. Number 4 requires a lot of thought processes, so please bear with me. The first thing it tells us is that TV bisects angle RTY. Bisect means cuts into equal parts. So that means that RTV, this angle here, is going to be congruent with YTV. Then it also mentions that arc RT, this arc here, is 112. It wants us to find the measure of VTY. That's our end goal. First things first, we need to find the measurement of angle XTR. Angle XTR is on the circle, and we talked about it early in the semester. When you have an angle on the circle, to find the measurement, you take the arc divided by 2. So this angle will equal 112 divided by 2, which gives us 56. And that formula is not on your chart, so you have to know this. Angle equals arc divided by 2 if the angle is on the circle. Now, what you're supposed to realize or recognize from is that XTR together with RTY, what I just highlighted in yellow, those two angles form 180 degrees because they make a straight line together. So with that being the case, I can take 180 minus 56 and figure out what that yellow angle would measure, and that would give me 124. So this angle measures a total of 124. Now, the angle we are looking for, VTY, is right here. It's 1/2. VTY is 1/2 of the yellow angle, RTY. So if I want to know what VTY is going to equal, I would take 124 and divide it by 2, and I would end up getting 62 degrees as my final answer. For number 8, it would like for us to use the picture from problem 7. So I need to zoom on that picture. So bear with me. I have to scroll back up a little as well as zoom out. So all this work that I'm about to do is work for number 8, okay? So keep that in mind. Make sure you put it under the correct problem. I'd hate for you not to get credit. All right, so it says if a point on the circle is chosen at random, what is the probability that the point is in sector EQC, which is supposed to technically be the sector formed by angle EQC. So the angle EQC is right here. So this is the area we are trying to land in or put a point. In order to do this probability problem, probability always involves your desired portion over your total portion. So our desired portion is represented by this green highlighted, these 2 pizza slices. The total portion would be the entire circle. So what I would need to do, So the big picture for this problem is to find the area of the sector and then divide it by the area of the circle. So to find the area of a sector, again, it's m over 360 times pi radius squared. So the measure of this angle, well, remember there was 80 degrees up here from earlier, and this 80 together with the 50 would make 130. Our radius is still going to be 6 because it said use the same information as before. So when you put this in the calculator in terms of pi, you would get 13 pi. Now we need to find the area of the entire circle. The formula for the area of a circle is equal to pi radius squared, which would be pi 6 squared. And in terms of pi, that would be 36 pi. So put it at the bottom. Now, if we were asked to leave it as a fraction in reduced form, you would put 13 pi divided by 36 pi in the calculator. And when you turn it back into a fraction, you would end up simply getting 13 over 36, because the only thing that's going to change is the pi is canceling out. However, they want us to write our answer rounded to the nearest 10,000ths. So let's see how this looks in our calculator, so you all will understand how to round properly. So I'm going to put 13 divided by 36, and 10,000ths is 4 places after the decimal. So if I round correctly, it's approximately 0.3611. I'm going to take a break right here and resume the backside in just a moment.